Okay, today we're learning about special right triangles, and then our next unit we're going to be moving into trig. Not next unit, the next lesson will be in trig. The first special right triangle is a 45, 45, 90 triangle. We know triangles. Sum theorem tells us that the sum of all triangles is a total of 180 degrees. And so this is a special one because if this is 90, then the other one is a 45, 45, 90. And the theorem basically says in a 45, 45, 90 degree triangle, both legs are congruent and the hypotenuse is the length of the leg times 2. In a 45, 45, 90, both legs are congruent and the length of the hypotenuse is the length of the leg times the square root of 2. So let's say this one is just a leg, that one is just a leg, they're both congruent. And so to find the hypotenuse, you take the length of the leg times the square root of 2, and that's how you can find the measurement. If you look on your formula charts, 45, 45, 90 degree triangles are on there. It says x, x, x radical 2. Same thing here, just x and x, and then you have x radical 2. And I put L just so you get in the habit of saying, okay, the legs are congruent because they're both 45, 45, opposite of the 45 degree angle, opposite of the 45 degree angle, and then the hypotenuse is that leg measurement times the square root of 2. So let's look at some examples. Find the value of x given your answer in simplest radical form. So we have this right triangle. This is 90 degrees, this is 45 degrees. By the triangle sum, we know this is also 45 degrees. And if we look across from this 45 degree angle, this one is worth 7. Since they're both a 45, 45, 90, we know the legs are congruent. So that means this is also 7 if you had to find that. But the question is asking for x in this problem, which is the hypotenuse. So since we know the leg is equal to 7, then we know that the hypotenuse is the leg square root of 2. So our answer would be 7 square root of 2 is our unknown. So whatever that leg is, you take it times the square root of 2. Got it? Here's B. We have a right triangle. We see that the legs are x and x. They're the same. So since those legs are congruent, we know that the only measurements can be 45, 45 because they're congruent in order to follow under the triangle sum theorem. And so in this case, it tells us the hypotenuse is 3. So we're going to go backwards and figure out what the x is. So since we know the hypotenuse is equal to leg square root of 2, so we know L square root of 2 is equal to 3 because it tells us the hypotenuse is equal to 3. Now we're going to go backwards and find out what the L is. And so you divide both sides by the square root of 2. And so our unknown, the leg is equal to 3 over radical 2. And that's our answer. Wrong. It's not our answer. Because if you remember, with radicals, you cannot have a radical in the denominator, so you have to rationalize. For those of you who forgot to rationalize, remember by rationalize you multiply by square root of 2 over square root of 2, because still equivalent to 1, but we're trying to get rid of the radical. And so this leg is equal to 3 radical 2 in our numerator, and square root of 2 times square root of 2 is the square root of 4, and the square root of 4 is 2, so this was the original measurement of the legs. Got it? Okay, we'll try another example. We have this triangle. It's a 45, 45, 90. We notice that across from the 90 degree angle is 16, so our hypotenuse is 16. So this is another one where we know the hypotenuse, which is L radical 2 or x radical 2. And you know what, I'll actually put x radical 2 just not to confuse them. So x radical 2 is our hypotenuse and it's equivalent to 16. We got to find x, so we're going to divide both sides by the square root of 2. X is equal to 16 over the square root of 2. Can't leave it like that, so we rationalize by multiplying by radical 2 over radical 2. And this is going to be equal to 16 radical 2 over square root of 2 times square root of 2 square root of 4, which is 2. And in this case, you see we can simplify that. 16 divided by 2, our answer is 8 radical 2. Everybody got that? And now we're going to look at an example. And I'll read it to you. Pause if you need to go, and rewind if you need to go back and reread. It says, Tessa wants to make a bandana for her dog. The bandana for her dog by folding a square of cloth into a 45-45 triangle. So you know you have a square and we can fold it in half into a triangle. So she wants to make a bandana for her dog that folds a square into a right triangle, and she said a 45-45 triangle. Her dog's neck has a circumference of about 32 centimeters. So his neck is about 32 centimeters. The folded bandana needs to be an extra 16 meters long so that she could tie it around her dog's neck. Round to the nearest tenth and round to the nearest centimeter and find the side length that the square of the square. I'm tripping. What should the side length of the square be round to the nearest centimeter? So this is what's given. Here's this bandana, and what's given is that from here to here it's worth 32 centimeters, and then here to here is 8 and 8, and so his circumference is 32, and in order to go around his neck, it said they need to add an extra 16 centimeters, and so that's the extra 8 and 8. And so we need to find the side lengths of the square, because remember this was originally a square bandana. She cut it in half, so right now we don't know what the side lengths are. And so if we look at it, this is basically the hypotenuse. When we add it up, our hypotenuse is equal to 48. So we're going to use 45-45 to find that. We know that 48 is equal to L radical 2. Divide both sides by radical 2. And if you want to try it on your own, pause the video, then come back and check your answer. That cancels, and so L is equal to 48 over radical 2. Rationalize by multiplying by radical 2 over radical 2. That gives us 48 radical 2 over 2. And so it says to round to the nearest centimeter. So if you put that in your calculator, it's equivalent to approximately 34 centimeters, are the side lengths of that triangle. And that sums up 45, 45, 90. Now we're going to pause the video. That's it.